So this one isn't just a which one doesn't belong. We want you to give a reason that each would not belong. And honestly, each of these are really great examples of everything we've learned so far. So we are going to put a lot of notes. Kind of write too big. And everything that I write down, you can tell me. So table 6, give me a reason why equation A does not belong. Okay, you cannot easily see the x squared. So class, does that mean that that one is not quadratic? All right, it is quadratic. It will create an x squared when I multiply it out. But what form is this? So it's the only one in factor form. So you cannot see the x squared. It's the only example in factor form. And really, factor form, I mean, this is probably the way we like to see it the most, like really simple like that. But factor form just has to be where you can still multiply it. So even like the stuff we were doing yesterday with GCF, you don't have to write this down, but something like this would still be considered factor form because it's before it's been multiplied. Everything else is in simplest form. And when we do multiply it out, we do see the x squared after it's been multiplied. So just really quickly multiplying it, I would get x squared plus 1x minus 12. Okay, question?
The nurse said I could go down to their office.
Okay, I'll write you fast in just a second. So that is why A does not belong. Questions on that? Okay. Table 2, why does B not belong? All right, it's the only one that has a different coefficient. What's the coefficient of the other ones? 1, good. So for that one, the leading coefficient is not 1. And that's why it doesn't belong. Even in the first one, the factored one, our leading coefficient is still 1, like leading coefficient because it's the first one in standard form. You'll also hear me call that coefficient A because in our standard form, we identify the coefficients as something specific. So A is always in front of the x squared, B is always in front of the x, and C is always the constant, the single number. So I'm also going to include here, A is not 1. I doesn't even say that a lot. Table 3, give me a reason that C does not belong. Good, it's the only two-term expression. We call those binomials. Only binomial, I'll say. And it's still factorable. It's the only example that is a difference of squares. So yesterday we talked about how you check for GCF first. There's no GCF between these two terms. But is it a difference of squares? Is there a minus sign in between them? Are they perfect squares on each side of the minus sign? What's the square root of x squared? And what's the square root of 25? So if I were to factor it, I know to find my square roots then because it is the difference of squares, write them like this in the parentheses and put one of them as a plus and the other one as a minus. Okay, so you could put for that one also, it's the only difference of squares. which we did that last Friday, so if you need to go look at those notes, or you have no clue what I'm talking about. If it's a two-term expression, you check, is it a difference, is it a subtraction problem? And are they perfect squares? If so, that's how you factor them. They don't do the diamond method for that. Lastly, table 4. Why does equation B not belong? Okay, it's the only one with no negative signs at all. Anyone else have another reason why it doesn't belong? Okay, you probably don't have enough of the knowledge yet, but we're gonna tell you. It's the only one of these that is not factorable. What do we call it when it's not factorable? So it's the only one that is a prime example. Now you might be looking at B and think that that one's also not factorable. I'll show you how B is factorable. That's actually going to be the main idea of today, is factoring stuff that looks like B. But you always check for a GCF first. So like if this was my standard form, if this was given to me and I was told to factor, then I would use my diamond method because it's a trinomial. I'm just doing it really quickly, so try to keep up, make sure we're paying attention. I would set up my diamond method and I would find two numbers that multiply to -12 and add to 1. So that would be 4 and -3 that do that. And if you notice, our factored form has that 4 and -3, right? So that one's factorable. C, we just factored it by difference of squares. B, I'll teach you how to factor today right now, but D is not factorable because if you look at it, there's no GCF. The numbers in front are 1, 2, and 3. There's never a GCF between the numbers if one of them is 1. And they don't each have an X. So if I were to set up my diamond after that, can you think of any numbers that multiply to 3 but add to 2? There's only two numbers that multiply to 3, right? What are they? Is there any way that I could play around with like a negative sign to where it multiplies to a positive that adds to a positive? Right? No, it wouldn't work. So when there's no two numbers that make it work after that, after checking for a GCF and stuff, that is why it's prime. Like there's no numbers that make it work. Okay. B is factorable, and I'm going to just briefly show you that. It might be a lot right now, but don't worry. We're going to give you some steps to follow. But it's still a 3-term expression. There's no GCF between 3, 8, and 5, and they don't each have an X term. So no GCF. If it's a 3-term expression, I still can use my diamond method. That's why I've been trying to condition you guys to remember that the top is A times C, and that the bottom is B. There's just going to be an extra added step at the end. So eyes open, eyes up here. Table 5, what would be my A times C for this one? Well, that's just my C. What about times it by A? Here's my standard form for reference. So it's 3 times 5. Okay, so that's what's going to go at the top. And really, you could kind of imagine it with this too. 1 times 3 is still 3, right? You can still multiply A each time. But right now, it's something other than 1. So there is actually a number here you have to remember to multiply. A times C is 15. Table 6, what's my B value for this? Close. -8 is correct, because the signs will make a difference when we're trying to pick two numbers that multiply to the top and add to the bottom. So everyone think about the two numbers that do that. Don't tell me it yet, because everyone think about it. Two numbers that multiply to 15 that add to -8. All right, table 8, what two numbers multiply to 15 that add to -8? If you're stuck, write down the factors of 15. So there's 15 times 1, 3 times 5, and that's it. So which combination could possibly give me a -8 when I add them? And to get a negative when I add them, they both would have to be good. And that works, right? Class, the two negatives multiply to a positive. So that's what you do if you're stuck. The stuff factors and then make it work somehow. Otherwise, it's not factorable, it's not factorable. But this is. Now, normally at this step, you would write this down. And normally you'd be done. But if I multiply this out, x times x is not 3x squared. So this is where that added step will come in. And again, we'll write down the steps later. I'm just showing you right now. The added step is to take that a value and divide it from your factor. So they call it slide, like you slid it over, you multiplied it by c. You need to divide it later on. So like slide and divide. Reduce the fractions. So 3/3 reduces to 1. 5/3 does not reduce further. Any remaining denominators, and you should have at least one, any remaining denominators are going to be slid in front of the variable. And then my final factor form is going to be x minus 1 and 3x minus 5. Now, if I multiply that together, x times 3x is 3x squared. And if I keep going, I do get -8x in the middle and +5 at the end. That's how you factor it. Questions? Okay, so really beefy warm up. Don't worry, we're going to give you steps to follow that you would need to have memorized by the time you test. But just going to touch on the goal today. We are going to transform more complicated quadratic expressions into factor form. So that's, for example, like equation B, that's what we mean. Checking for a GCF first, factoring out if I need to, and then continuing to factor again if I need to. And checking your answer by multiplying it out. I'm recording right now. I update it every year. I like to think that I get better at teaching it every year, so that will always be right here. But the math doesn't change. Look up other videos. Other methods are out there. I'm just showing you the one that I think is easiest. So free is a great resource. Yeah, we were practicing Schoology today. And I made the study guides available to you. And the IXL extra credit has been available to you for even longer than that. I sent out a message on Parent Square, like, I really need you to read it. Parents/Student Square, whatever you have. I need you to read it. There is no replacement for doing well on the things that are coming up. Right now, for like the next week or two, we're mostly just doing like homework points, right? There's not really other assignments other than homework for like the next week or two. But then you'll have all these projects, all these binder checks, which by the way, like we're doing less than 10 today. So we're really like at that halfway mark of all the notes that allowed for this unit. These need to be good grades. Like for example, I have one student that would normally be at like a B or a C, but they have a D right now because they have a missing minor check. And I keep telling them to resubmit it, and they don't. So they're just at a D right now, even though they score pretty good on tests. So like, start getting your binder ready now. Make sure you have all the half of the unit that we already did. The list is in Schoology, so that you're ready. And then you'll see like they come by really fast. The unit test will be here May 8th, the retake shortly after that, your finals shortly after that. So like read that message, all my tutoring dates for the semester are in there. Saturday Academy is this Saturday and then only 2 other Saturdays after that. I'm not making more tutoring dates. I'm telling you in advance when I'm available. But of course, like the other algebra teachers are also willing to help you do this kind of dates. Questions? Okay. Well, then moving on, let's give you some steps to write down so that you can copy this process on your own. But before that, let's review going from factor to standard form. So this was a unit 6 skill. Just very quickly multiply these out whatever way you like. You could FOIL, you could double distribute, which is taking a first term, multiplying it by these terms, second term, multiplying it by the other terms, or your area model. You can do the same method for each, you can try different methods, but this is basically how you'll be able to check your work to see if you factor things right, is by multiplying it out and see what you get. So just take like 2, maybe 3 minutes, work things out, we'll go over them shortly. I think I'll just project them, because honestly, like, it's working. So have this worked out. But I haven't gone there yet, but really it shouldn't take that long. So for the first one, table 9, what would my standard form be of this factor form? Yes. Okay, good. And then in an earlier class, when they told me the answer, they told me like plus 12x plus 1x, like they told me before they combined like terms. If it asks for the standard form, make sure it's all combined over. But that is correct. Table 1, what would be the standard form of this factor form? All right, so like my 2 middle terms would have been 6x plus 2x, so that's why it's 8x in the middle. And then table 2, what would be my last one in the standard form? All right, and then again, that is the 2 middle terms would have been 3x plus 4x, so that's why it's 7x. All right, questions on multiplying? Are we good on that? Okay, it's just a way to check. Like at least when you get your answer, at least check for the leading coefficient, because that's usually where students forget. They'll forget to like divide the A. Whatever you are multiplying needs to give you the original if you factored correctly. All right, but on to this example, it's like going to be a teacher example. Let's skip this one. Let's just go right into this one, which has a place for you to put some steps and a place for you to put the scratch word. So your first step should always be in any factoring situation to look for and factor out a GCF if necessary. Because there won't be a GCF in every single problem, that's why we say if necessary. But if there is, you have to factor it out first, otherwise you will get the wrong answer if you continue with the rest of the steps. So looking at our guided example, table 3, Is there a GCF between 428 and 45? Remember, GCF can never be bigger than your smallest number, so check. Does my smallest number divide evenly into the others? Like, does 4 divide evenly into the other numbers? It doesn't. It divides evenly into 28, but not 45. So can't be 4. Break 4 down into its smaller factors. So here are all the ways to multiply to get 4. We already eliminated 4. And then start by eliminating the greater ones, because we want the greatest common factor. Is 2 divisible into all 3 of these numbers, class? So no GCF. And then after that, the only other factor is 1, and 1 doesn't change it. So, thank you. Yes, please. So look for and factor out a GCF if necessary. There's no GCF in this one. We're going to move on to step 2, which is check the number of terms. So if I have a 3-term expression, even when A is not 1, we're still going to use the diamond method. Let me make that look more like that. So if it's 3 terms, we're still going to use the diamond method, and really the process will be the same. There's just one step I didn't say before, because when A is 1, like it doesn't really change much at all. When you multiply, everything will stay it. But if there's 3 terms, you do the diamond method. If there is 2 terms, you check to see if it's a difference of squares. But this one's a 3-term. So we're going to do our diamond method. We're going to do A times C on top, B on the bottom. Table 4, what will be my A times C for this one? Okay, so that's my A and my C, multiply them together. Not the x squared though, we never include the variable, just the number in bracket. 180 is my top number this time. Table 5, what's my G term? Here is your standard form of a quadratic for reference. What's my D term? 28, that will go on the bottom. And still, we are looking for 2 numbers that multiply to the top, but add to the bottom. Now, everyone think about it. Don't say it yet. There's a lot of factors of 180, so that's where it can be kind of like frustrating for some people. For some people, it might come really fast. Like, does anyone know already what 2 numbers multiply to 180 that adds 28? If you have it, you can tell me. Yeah.
12 and 15.
Okay.
Oh,
Do they add to 28 though? They add to 27. So we're kind of close-ish. I started by writing out the factors of 180. I'm not done yet though. But if anyone else has the 2 numbers that make it work completely, let us know. Mandalay? 10 and 18. Right, do you guys agree? Do they multiply to 180, add to 28? All right, so we found them. But just for reference, like if you ever get stuck, I kind of just start going down the list of numbers. like seeing if it's divisible by 1, 2, 3, 4. It's also divisible by 5, 6. I don't think it's divisible by 8. It might be, I don't know. But there's a long list of numbers that could multiply to give 180. There's only 2 that will make it work for the whole thing. Okay. So there's that. We found the 2 numbers that make it work. So far, we have this. But if I were to just stop there, I would not get that 4x squared when I multiply. So this is where the added step comes in. So for our next step, we need to divide each factor by a. And reduce the fraction. Make that the same step. Divide each factor by a and reduce the fraction. Table 6, what was my a value in this? It was 4. Right, that was my a times c, 4 times 45. 4 was my a. Sometimes they call it slide and divide. So originally they slid it over, they multiplied it by c. Well, in a later step, you have to divide it from your factors. You have to reduce the fractions, which I understand can be hard sometimes. You can use calculators to do that. And you can also use calculators to find GCF. I've never done that, but like it could tell you the GCF between 2 numbers. But for reducing fractions, I'll actually probably use a calculator a lot of the time. All you have to do is type in the fraction. If it gives you a decimal, almost all calculators have a decimal to fraction button, and it's this button on Desmos. And it'll always give me the most simplified fraction. So right now I have it as x plus 5 over 2. And now we need to reduce 18 over 4. I'm going to click the decimal to fraction button. 9 over 2 is what the other one is reduced to. Okay, but I mean, this might help us easily see our zeros. But for the factored form, there's one more step. You need to slide any remaining denominators. Slide any remaining denominators in front of the variable. So like for this one, I reduce the fractions to this. After reducing the fractions, any denominators that remain, we're gonna rewrite it, but in front of the x. So we're sliding it in front. So you can think of it as slide, divide, slide. And our final factored form ends up being 2x plus 5 and 2x plus 9. Now when I multiply it out to check my answer, I am getting that 4x squared. I would get 10x plus 18x, which is what? No, I get 10x plus 8x. Oh, wait, no, I was right the first time. 10x plus 18x, which is 28x. And then multiply our last 2 and we do get 45. All right. The next examples won't go that slow, but it was kind of slow because we had to write out all the steps. You do need to know the steps for your tests. Your test is not just going to ask for solutions, it's going to ask for the next correct step. Questions? Okay, so the next one will go a little faster. I do have the steps on the next page as well. We're going to do maybe a couple together and then I'll give you a couple to try. So on the back. Let's start with first one. I have my steps up here if you were still writing those down or need your reference. But first you are going to check for and factor out a GCF if necessary. So everyone look at this one, think about it yourself. Is there a GCF between 6, 1, and 2? Technically there is, it's 1, but we don't care if it's 1. Dividing by 1 doesn't change anything. So no GCF between the numbers. Do they each have a Y? So no GCF between the variables either. We can move on to the next step, which is factoring. And since it's a 3-term, we can use the diamond method. A times C will go on the top. So table 1, what will be my A times C for this one? What did you say? -12. All right, so slide that's 6 times it by the C value. -12 is our A times C. Table 2, what's our B value for this? -1. The negatives do matter. The negative, we need to put that as negatives. It'll change the numbers we take to make it work. Table 3, what 2 numbers multiply to -12 but add to -1? -4, +3. Any questions, any disagreements on that? So, does multiply to a negative, does add to a negative. So far, what we have for our answer will be this. And I'm gonna not make it an X, I'm gonna make it a Y. So Y -4 and Y +3. So far, we're not finished. Because when A is not 1, and you could still, like in other problems, if you want to divide the 1 here, like go ahead and change anything. But when A is not 1, you need to make sure you divide it from the factors. Because right now, if I were to multiply, I would not get 6y squared for the first. So you have to do this step. Reduce the fractions, use a calculator if you need to. Class, what does 4/6 reduce to? We had to do in the calculator earlier, we gotta stop just like getting questions wrong because we don't wanna either know our fraction rules or know how to use a calculator. Press this button and it'll give you the reduced fraction. Last time I told you. Oh, it next time. So class, what's this 4/6 reduced to? 2/3. Let's see. Class, what does 3/6 reduce to? All right, this helps me easily see my zeros. Like if it was asking for the answer to a quadratic, my x-intercepts, I would say that it's 2/3 and -1/2 for my final answers. But we just want the factored form today. So to continue on with these steps, we need to slide any remaining denominators in front of the variable. And that will reveal the true factored form. So sliding the 3 makes it 3y - 2. Sliding the 2 makes it 2y + 1. Now if I were to multiply it out, I get the original. I get 6y squared -1y -2. If you get. let's do a problem together where there is a GCF that we need to factor out. So I'm gonna scroll, but if you're also writing, right. Okay, go scrolling to this one. Look, this one, they're not numbered, so look at the one that looks like this. We're doing this one together. So always check for and factor out a GCF if there is one. Table 4, what's the GCF between 2, 2, and 24? 2, good. Can never be bigger than the smallest number. 2 is divisible into all three of those numbers. Class, can I factor out any variables? No, because they don't all have an A. So my GCF for this is just going to be 2. It's going to be outside of the parentheses. And as long as we keep writing it outside of the parentheses, we won't have to do anything else with it. Okay. Other than, you know, inside the parentheses needs to be what we get from dividing each term by our GCF. So we're going to do that now. 2 over 2 cancels. Same thing over here. I end up with a squared plus a, and then class was negative 24 divided by 2. So I end up with that in the parentheses. Now, we factored out a GCF. We need to keep seeing if it's factorable by anything else. So just look at the parentheses, just look at what I wrote in the red. It's a 3-term expression. Notice that the leading coefficient is 1 though, so it's going to actually be an easier one to factor. But still, when you set up your diamond, it's A times C. 1 times negative 12 is negative 12. Class, what's my B value? Not A. 1. Because we never put variables in this. We just put the numbers that are in front of us. So my B value is 1. And I'm not looking at my original problem. I'm just factoring what's in the parentheses now. Now we are looking for 2 numbers that multiply to negative 12, but add to positive 1. Table 6, what numbers do that? Add to the, or multiply to negative 12, add to positive 1. Would they add to a negative, or sorry, would they add to the positive? So how can I adjust it? Okay, you said the same thing again. 3 and negative 5, negative 3 and positive 4. All right, class, that makes sense. Multiplies to the negative, adds to the positive. All right. So my GCF is still going to be in my answer, but now my parentheses are going to be, at least right now, well, actually it is for A is 1, so we're actually going to be done. My parentheses are going to be A plus 4, A minus 3. And because my leading coefficient here was 1, I don't really have to do anything else. My leading coefficient is not the GCF. Okay. If I were to keep dividing, like my A was 1, dividing by 1 doesn't change it. That's why we didn't really talk about it before, but really it is the same step. And then slide in your remaining denominators in front. This is our factor. All right, good. Questions? All right, I'm going to give you a couple to try. I want you to try this one. And then I want you to also try the one that's above the one we just did. Because there's no way I can probably have you try them all, although I do think the notes are in school if you wanted the other examples. This is what we'll have time to go over today. We'll try those two. Yes. Raise your hand if you're completely done with the one that I'm hovering over. Okay, raise your hand if you're done with the other one, this one. Okay, I'll start with this one then, because I don't know, more people probably attempted that one because it was the first one I said to try. So let's try it. Following the steps, look for and factor out a GCF. Is there a GCF between 12, 2, and 2? Class? Yeah. The smallest number is 2. It does divide evenly into the others, so I do have a GCF. Do they each have an X? So no GCF between the variables. Just my GCF is 2 right now. That makes me rewrite it like this, with my parentheses being 6x squared plus x minus 1. Okay, so GCF on the outside, these canceled. This is what it looks like at this step. Now, continuing on, check your parentheses. See if they are still factorable. My parentheses have a trinomial, so we're going to do the diamond method to continue factoring. This is my A, this is my C. Slide that A over, times it by C. Class, what's 6 times -1? -6. And then set up your diamond. What's my B value? Asking all of you. 1. Now we're looking for two numbers that multiply to -6, but add to 1. There's only a few ways to multiply to 6 in general. Here are a few ways. Which one could possibly give me a 1 when I add or subtract them? Not the 6 and 1, right? That would be like what? 7, 4, like for 5, like there. So try the 2 and 3. Since we multiply to a negative, one of them has to be negative. Which one does it have to be? The 2. It has to be the 2 if we're going to add to a positive. So at this stage, my parentheses will look like this. But we're not finished because I need to divide my A. And not my A from like the very original, my A from this. We're just factoring. So my A was 6. We're going to divide both of those by 6, reduce the fractions. Calculator if you have to. Class, what does 2 over 6 reduce to? Good, 1/3. What does 3/6 reduce to? Good, and then you need to slide any remaining denominators in front of the variable. This is like the best way for me to write it to make it look neat. My final answer ends up being 2 outside of parentheses because your GCF needs to still be there. Then 3x minus 1 and 2x plus 1. That's how you can multiply to get the 6x squared for your being posted in the parentheses. All right, one other thing. So like I mentioned, this is how I make it look nice and neat so you can understand it. When I'm normally just doing my scratch work, it'll usually look something like this. Where while I'm still in my diamond, I'm dividing by my A, reducing the fractions here, so it ends up being like 1/3, 1/2. And then just I know when to write it, that this has to be slid in front. Again, I don't really recommend that for note taking because you might know what's going on later, but like That's their opposite. All right, I don't think I have a whole lot of time to step by step take you through the other one, but just briefly, I'll show you. There's no GCF at all. So when I set up my diamond, it ends up being -60 on top, 11 on the bottom. Two numbers that multiply to -60 but add to 11 would be 15 and -4. Then I need to divide by A, which was 12. Reduce the fractions. It ends up being 4C plus 5 and 3C minus. All of these examples are worked out in the notes that are listed online. Practice, but you also have your online practice. You need to know the steps. Questions, comments, concerns? Okay,